Cell arrays are one way to store heterogeneous data. For instance, you can store numerical variables, matrices, arrays, strings, character vectors in a cell array. A cell array is a kind of a linear data structure. If you want a more tree-like data structure, you can use the concept of a structure. I will show you in this example script how to create a structure, how to create fields, how to assign values to the fields, and so on. So let's step through the script example underscore structure. I start with clearing the memory. I also clear the workspace, the output window, the command window, and I start with creating a structure with a name, triangle, and fields A, B, C. So this is supposed to represent a triangle with 3 vertices, and the fields A, B, C each contain a 2 vector, a row vector of dimension 2 or length 2, and this represents the position of the vertex in the xy plane. So I can assign the fields A, B, and C. We have now the 3 vertices of the triangle. And if you want to know what the current field names are, you ask the function field names. And these are just capital A, capital B, capital C represented or presented in a cell array of 3 characters. You can further expand this structure triangle by adding an area. Now the area is of course a function of the vertices A, B, and C. So I've written a small function which computes the area. It's down at the end of the script. It takes 3 vertices as the input and returns the area, capital F, as the output. And this is a formula for computing the area from the 3 vertices. So let's put a breakpoint in line 48. And then let's return to our current position in line 8. If I now execute line 8, we call the function area, and we will hopefully stop at line 48. Yes, we do. We'll talk a lot more about functions later, so this is a very, very simple example, but it's sufficient for our needs at the moment. So this takes the vertices A, B, C and returns the area F. Okay, this is a single statement. Now let's have a look at the value of the area. F, it's 5 square units. And then we return to the script. We have now computed the area and we have stored it in the structure triangle. So let's have a look. We have now another field which is called area, and its value is the scalar 5. Of course, the field names will reflect the 4 names of the fields. If you're not sure whether there's a field for the angle alpha, you can call the function isField. Well, there is currently no field with the angle alpha, so this will return a logical false. Yeah, here it is. Now we can create a second triangle. I simply copy the current triangle, triangle 1, to triangle 2. We have now 2 instances of this structure. And triangle is now an array of structures, a 1x2 array of structures. And all elements in this array have to have the same fields. So naturally, triangle 2, the new triangle, also has 4 fields, but we can of course change these fields in the second instance. For instance, I can change the location of vertex A. The area is no longer correct, so let's remove the field area. This can be done by the function rmField, remove field. And this field is removed in all instances of the structure in this array of structure. If you're not sure whether a certain variable in your workspace is a structure, you can call the function isStruct. So isStruct triangle should give a logical true, because triangle is actually a structure or an array of structures. Right? We get true. The fields are not structures. So this line should give a logical false. Now let me show you a second example. For instance, I want to describe myself and my kids. So I define a structure with a name person. The first field of this structure person is the name, the last name. Then I add my first name. And then I add my children, my sons. I have 3 sons, so child is now an array. And each element of this array has 2 fields. The first field is first name, and this is a string array, so that I can store more than one first name, or I can store a middle name if you want. And the second field is the age. So I add 2 first names for my first son. He's called Stefan Adrian. His age is 26. So this is child 1. Child 2 is my second son, is his twin brother actually. So I add his first name, which is Matthias, and his age, which is also 26. Then my youngest son, his first name is Felix, and his age is 23. And this concludes my person plus my children. Now, if you want to know the number of children of a certain person, you look at the length of the field person.child. This is 3. Now I want to know the number of first names and the ages of all the children. And here it's allowed to write a loop. This loop is not going to run very often, actually from 1 to 3. So this shouldn't be a problem in terms of execution time. So let's step through this loop and let's extract the number of first names for each of the children. And this number is just the length of the field person.child ich, the current child, dot first name. And age is extracted from the field person.currentchild.age. You notice that the name of this field and the name of this vector are identical, and this is of course no problem, because the address of this vector and the address of this field are certainly not the same. Okay, so let's step through the loop, just 3 iterations, and then I can show the number of first names for each child, which is 2 for the first and 1 for the other 2, and the ages. And the ages are 26, 26, 23. Now let me add my wife to the family. So I define a second person. And the easiest way to do this is just to copy my information on the second person. So this is done by this command. And then I have to change everything which is different. Our children are the same. So I basically have to change her first name and her last name. So I set person2.first name, her first name is Silvia, and her last name is not simply mine, it's a double name. So I set her last name to this string. This can be done also by the function setField. So I assign the output of this function call again to person2, and I ask to set the field in this structure, the field with this name, to this value. So this is the person, the address of the person, that's the field to be changed, and this is a value to which the field should be changed. If you just call setField without assigning an output, it will not change the structure person2. It will just give an output with a changed name, but person2 itself will not change unless it's assigned as the output of the setField function. You also can use the function getField to extract information from the structure. So, for instance, if I say fn, first name, equals getField of person2 first name, I get the first name in the variable fn, which is exactly the same as just assigning fn to person2 dot first name. So there is absolutely no difference between these two.